Hello, everyone. Welcome to our today's lecture of Machine Learning Interpretability. My name is Radwa Al-Shawi, and I'm Associate Professor of Data Science at University of Tartu. So, after completing this micro lecture, you will be able to understand the concept of interpretability and also understand its significance. You will be able to differentiate between model interpretability and model accuracy. You will be able to identify key approaches to explaining machine learning models. So we will start with a quick introduction to machine learning interpretability. We'll be talking about model accuracy versus interpretability and also key approaches to explainability. So in general, there is no wide agreement about a specific definition for machine learning interpretability. However, one way to define it is the degree to which human can understand and comprehend the cause of a decision. So, as you know, machine learning achieved great success in many application domains, in self-driving car, in healthcare diagnosis, in recommendation, in face recognition, and many more. So, as a user of machine learning model, when we have already a trained model and this model is making predictions or decisions, as a user, we have trust challenges. So we need to understand, for example, why the model is making these predictions. And also we need to understand, is a model is making correct predictions for the right reasons or not? So for example, if we have a specific machine learning model used in a bank for predicting whether the loan application should be accepted or rejected. And for example, if I am the client of this bank, and I applied for a loan and my loan application has been rejected. As a client, I need to understand why. I need to understand why my loan application has been rejected. And also I need to understand what can be done in order for my loan application next time to be accepted. Machine learning interpretability is very important, especially in critical domains, like, for example, in self-driving car or in healthcare diagnosis. In these applications, wrong decisions can be very costly and very dangerous. So the question is, can I trust only machine learning models based on accuracy? The simple answer is no. And let us consider this example. So this is an example for the machine learning model for predicting the risk of pneumonia. And this machine learning model is very accurate. So in terms of accuracy, it has a very high accuracy. But when researchers try to understand the reasoning behind the predictions and why the model is behaving like that, they discovered that the model learned that the patients who have history of asthma have a lower risk of dying from pneumonia than general population. And this is actually counterintuitive. The true thing is that patients who have a history of asthma and were usually they were admitted to intensive care, and aggressive care they received decrease or lowering the risk of death from pneumonia compared to general population. So for example, if we have a model like this model, it's an accurate model, but imagine if this model has been used in production, it could have led to severe problems. So in general, it's very important to understand the behavior of the model and why is the model is making such predictions. Another also example for why shouldn't we trust machine learning models based on accuracy is an interesting example taken from the paper cited at the bottom of the slide. It's for a state-of-the-art interpretability technique called LINE. So in this paper, they highlighted these interesting examples. So that there was a machine learning model. In terms of accuracy, it's an accurate model. As you can see, that is trying to differentiate between husky and wolf. And as you can see here, it's quite accurate. So the labels here, the predicted labels and the true labels matched across the majority of the instances here that we have. But when they try to understand the behavior of the model and why the model is making these predictions, they used a tool called LIME to provide explanation. So for example, here you will find the image, and this is the explanation. These are parts of the image that contributed to the predictions. The same here, the same here, and the same here. If you have a look on all the wolf images that we have here, you will find that the explanation is mainly due to some parts or some snow parts in the background. So here, instead of building an accurate model that is trying to differentiate between husky and wolf, it ended up that we have a great snow detector. So usually there are some interesting properties that should be satisfied by the explanations we provide from machine learning interpretability techniques. The first one is the faithfulness. So the explanations should be able to accurately represent the true reasoning behind the model's final decision. And the second property is understandable. So the explanations should be understandable, means that users without in-depth knowledge of the system can understand it. Also, the explanations should be stable somehow. So similar instances somehow should have similar kind of explanations. Now, how can we evaluate explanations from interpretability techniques? Usually we have two methods. The first one is human-based evaluation, and the second one is functional evaluation. The human-based evaluation, usually we set up some mechanical Turk task and ask non-experts to judge the quality of the explanations. The second way to evaluate explanations from interpretability techniques is through functional evaluation, in which we have some quantitative measures that can directly test some properties of the explanations. In general, the topic of machine learning interpretability received great attention, especially after the General Data Protection Regulations imposed in 2018 that requested decisions taken automatically to be explained. So, for example, in the case of a bank, for the loan application example, the bank must provide explanations for their clients why the applications has been rejected in order to comply with the GDPR. Usually, there are two ways to provide explanations. The first thing is to use models that are transparent models that are inherently transparent. Something like, for example, logistic regression, something like a shallow decision tree, for example. The second way to provide explanation is that we can build, we can have, for example, a black box model, and we add a layer on this model in order to provide explanation. So in this layer, we can use two types of techniques, global techniques or the local techniques. In global techniques or global interpretability in general, we try to explain the general behavior of the model. We try to answer the question is, why is the model is making this prediction? The other kind of explanation, which is the local explanation, we try here to provide explanations for specific instances in our training data. So for example, if I have a machine learning model for predicting a specific risk, for example, risk of diabetes, local explanations can answer questions like why this patient has been predicted as high risk of diabetes or low risk of diabetes. So we care about explaining the behavior of or explaining the decisions of specific instances in our data. Thank you so much for listening.